Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Sansui stereo receiver 771. A very nice example of one too. I don't know if you can see, it's pretty nice. Except for maybe a little bit down here. Some very minor scratches. But this is a client unit, so it's time to pay some bills. And I've been working on a lot of things right now. I've got probably 4 things on the go, and I'm trying to get things completed through the summer, but time's against me. So this is client unit. He wants to go through it and make sure it's all 100%. He supplied me with an LED retrofit kit, and we'll see what we can do with this. He says I can use it or throw it away, but I feel bad for people when they pay big bucks for a kit like this. I can imagine what this costs. It's probably, to buy you a good meal at a nice restaurant. But, if you just get the individual components yourself, you can do this for just like pennies. So we'll use that. We'll use that up, and we'll get this going. So it's a little bit dirty, especially in the back. It's nicely optioned out. It's got 3 sets of speaker outputs. We have 2 tape loops, phone auxiliary, a DIN plug for 1 tape deck, your usual tuner, controls, Kerchunk power switch, and 20 dB muting, high-low filters, bass treble, balance. It's all pretty standard affair here. Loudness, mono, tape monitors, FM muting, and then our input selection. So I don't know if there's anything wrong with it. I don't think there is. But let's plug it in and test it and see what it does or doesn't do. Okay, I think I'm ready to go here. Let's just look at the power cord. It's pretty. Starts right about, where is it? Here. There's a big nick. It's not bare copper yet, but and there's a heavy abrasion. Probably just going to replace this cord. It's pretty stiff from age. I'll just put a new one on. I think that'll spice it up. So let's try this out. Can you read that? Okay, here we go. Oh, relay click. We've only got half of our dial lit. What do we have for audio? Speakers A. Yeah, connected to speakers A. Well, that's phono. I don't hear anything. It's nothing at all. It's like the power amp isn't working. Just wondering if it's maybe a really dirty relay. Let's try it again. Relay. Absolutely silent. Nothing on the scope. We got a tone on auxiliary, so let's turn it to auxiliary. A little bit on the left. The right is very quiet and distorted. Oh, here comes the right. It's late to the party. That's probably a dirty relay or switch. It sounds clean now. Dirty switches. 17.5. Let's switch this over to the load. I'll put you up on the scope. Okay, so have a look at this. The left channel is freaking out. The right channel is low. If I play with the switch is all messed up. Let me reset it and turn the relay back on again. Yeah, it's dirty relay. Give it some power and it cleans itself. Give both channels power and they clean themselves. Okay, it's a little twitchy. I don't know why it's so twitchy. Let's try a square wave. Ooh. There's definitely something going on in the left channel. Let's see what it does at some higher power. And it's going up. There's clipping. Let's go back to sine wave. Does some pretty good power. Let's see. Let's measure that. Okay, going up to clipping. Ooh. There's clipping there. I'll back it off. Right to that point. At 19.04 volts RMS. I don't know what this is capable of, but that's the highest power machine. Okay, so that's pretty typical for a receiver that you just plug in out of the blue and start using it. At first it won't even work, no audio at all, and then once you start playing with the controls, working things, they start to come back to life. And right now we got a fairly clean signal on the scope on both channels, and I'm assuming it's pretty full power, but this will get the full deal of switches and pots, because it's going to need it, and relay contacts for sure, some new lamps, and this switch needs to be cleaned. What else? And then probably give it a full cap service. We'll see how it performs after that. Okay, I should also mention our AM and FM tuners are totally dead. There's no sound. It's completely quiet, so we have to repair that as well. Alright, let's look at the lid here. And it looks like a vinyl wrap on particle board, plywood. I'm not sure, it is plywood, but it looks like a wrap. I don't think it's a real veneer, because you can see shrinking here. Right here, this piece is shrunk, and then this piece is shrunk, and it's exposed the subwood. Yeah, this would probably look good with a nice new oak topper. Anyways, let's have a look inside. It looks good. So we got a very nice example of an unmolested receiver from Sansui, early 70s. Looks very nice. Doesn't look like it's been worked on. So obviously this is all tuner, AM FM tuner section. Along the back we have our driver board. Down underneath we have 4 TO3 transistors on this bit of extrusion here. So here's the transistors, there's our driver board, here's a power supply, Power supply here, power supply here. There's our relay. A little bit of cooking going on. See quite a bit of cooking with this resistor. This transistor this one's been replaced. This is not an original transistor. And look, it's flopping in the wind. I'll probably just pull it out. No, but it is not soldered in place anymore. That might be our tuner problem right there. Somebody's been in here a few times. You can see how chewed up the Phillips is. And somebody tried pliers on the outside of the screw. I'll have to see. I got some replacement screws, but if it's not too bad, you can clean it up with a file or a stone and just get it so it's not sharp anymore. And it looks a lot better and it doesn't cut you up. Okay, it's all starting to make sense now. So I pulled the bottom cover off and I see this. Oh my God, people, don't do this. Look at, they use wood screws and they're about 3/4 of an inch long. And what did that stab? You know, that's dangerous, man. You could crack boards, you know, puncture wires. You can do a lot of damage. So make sure you get the right hardware. So where does that land? That lands right here. This one's an open space. This one lands right on the power cord. This one is right in the power amplifier, but thankfully the power amplifier is recessed and it missed. Yeah, that could have been bad. Don't use wood screws like that. Get the right hardware. We'll change that out for, it should be M4 for these. So M4 self-tappers. Or machine thread, depending on what was there. Okay, can you see all this? It looks untouched. Somebody's been tightening these or turning these nuts on the transistors. So those, because those nuts were soldered in place, I think. Maybe not. But that's your collector connection, so they got to be good. These got to be tight. No, everything else is untouched under here. Okay, my plan is probably start on the tone board, pull the tone board out, and do all the caps and switches and pots, and get the worst out of the way first, and then put this back, and then we'll just work on our power amplifier and power supplies. Now before you start any work on one of these receivers, you have to go through and photograph all the wiring connections. Take pictures of all these, because if you're flexing a board and one wire snaps off and then you're wondering where did it go, where did it come from, and then if you have photos you can always look and see where that wire attached. And take pictures of all this. It doesn't take, it takes like 30 seconds. Take pictures and then you have a record of it. I'm actually helping one guy right now through email. He had a Nakamichi receiver. His son pulled all the connectors off, and now he's trying to figure out the puzzle. And I can't help you because I don't know how you can show you the manual, but I don't have the receiver in front of me, so I can't tell him where to connect which wire. But it's all laid out in the manual if you go through and read it. Same with up here. Do these. And these, if you're going to be working on tuner, anywhere where you plan on doing work, these wires, I'm not going to be disconnecting them, so I don't need to photograph anything in here. But I'll probably just take pictures just for my own records, so I know if somebody asks me about a board, somebody emails me and asks me about something on a board, and I can pull up the board and look at it and see. But yeah, so I'll get through this. And then I'll start removing these nuts. Actually, we can start that right now. starting with the tone board here. I desoldered all the potentiometers and all the switches, and they're all coming out because somebody hosed the entire board down with some kind of a treatment, and it's just made this slimy mess everywhere. Everything's coated with an oily film, and these switches, I don't know if you can see the grease. See the grease on the plungers. They're really dirty. The dust has gotten in there, and they really don't feel very good. So this got to be all disassembled and cleaned. Otherwise, the other alternative is replace the switch. I do have new switches, but if you look here, they are not quite the same length. You see how they come short and they don't reach the board, so that's no good. So these switches won't work. I'm gonna have to do the cleaning on this, and yeah, it's a mess. Same with these pots. The pots are not that big of a deal. They're all covered with some kind of a slime, but that's on the outside. On the inside, we'll treat the inside and we'll get them working. I'm just removing everything from the board because we're gonna clean this board. It's got an oily film on everything. I don't know if you can see this. It's just nasty. So I'm going to spray this all down, but the solvent I'm going to use could probably destroy these styrene capacitors. So I'll have to remove these two styrene capacitors here, and this one up here. You can't see it. There's a styrene capacitor here, and then here and here. I'll remove those three so that the solvents don't destroy those caps. Clean the board, give it all a good cleaning. There's also some tantalum caps on here. Now I don't know, this is a 1.5 microfarad. I could replace that with a film cap. I don't know what effect the oil has on these capacitors, or any of these components for that matter. You start spraying components with an oily substance, it could absorb into the component and it can change things. Transistors and resistors are usually safe. I'm just saying usually because I don't know. A lot of these green capacitors should be okay. The electrolytics will go. We'll put new ones in. But other than that, I just want to make sure that it's all 100% when I'm done. We got a FET down here. And these are all 2SC 1313s. I think those are on my naughty list. Let me check. Yeah, 1313. Can replace them with either a 2SC 2240, KSC 1845, or BC 337. I'll figure out which substitute I'm going to. Probably the C1845s I'll replace them with. So I'm going to get started on this board. Okay, I'm just going to wash the board in place. I got it positioned here so it's just going to drain down. And I have, you can get a cup or something to catch the liquid, but I'm just going to use a rag just to absorb it as it comes down. And what I'm going to use is my favorite, is tetrachloroethylene. And I'm just going to give this a shot. Just get it a hose down and give it a bit of a brush. All that oil and crap, it'll dissolve all that oil. You can see how clean it's coming. It's going to brush it down and flood it. This will get the majority of the dust and the grime off. And then we can work on recapping. So already it's looking 100% better. The silk screening is coming back to white again. It used to be kind of a dull brown looking. Let's go down and do the bottom of the board. Okay, let's give it another shot. keep going till you hit the bottom, clean it off. Now I could have removed the board if I unsoldered maybe 20-30 connections and put this in the ultrasonic, but I don't think the ultrasonic would do much for this oily grime. It would probably not do much because I just use water and detergent in the ultrasonic. See, that's come out really nice looking. Got some rosin flux here. That's a lot better. Clean that up quite a bit. Okay, I'm going to go through and check all these resistors because I'm not confident that that film or whatever has affected any of these parts. So all the caps will get changed. Check the resistors. I'm probably going to replace some of these transistors. Here's a FET. There's 2 FETs here. Leave those alone, but these ones, these 1313s, 2SC 1313s, they'll have to get replaced. And we'll take it from there. There, it already looks a lot better. It's clean. Okay, so I've spent all morning flushing and cleaning these pots and switches. A lot of crap come out of them. I used MG Chemicals 401B control cleaner. Now this has a lubricant in it, so when I was done you can still see there's lubricant inside. The switches are actually not bad. You can see inside the back side of these switches, and there's really no tarnish. Just like on the tops, you don't see too much tarnish. So whatever somebody sprayed on this, it was like a white lithium grease or something. Somebody sprayed all over everything. It kind of protected the metals from corroding. You can see it here. Even on these legs, they're not that badly corroded. They're starting to tarnish, but they're not that bad. So I think with this, I flushed these out with the 401B, and now I'm just going to follow up with a treatment of Deoxit D100. And I'm just going to spritz a little back in the back of each one of these. Very small amount, I can't see here. Hang on, let's do that and do this. And we'll just get this wet with red Deoxit. Did I get them all? I think I did. I think I missed this one. There. And just work the contacts a few times just to spread it around. And these can go back on the board. Okay, same with this one. And the potentiometers, I'm just going to follow up with a treatment of F100 Deoxit, the green. And I'm just going to place a little drop on the wiper. If you look in the window here, you can see the wiper. And I'm just going to reach in with the tube and just place a drop right on the contacts of that wiper. Very careful when you do this. You don't want to manhandle it and go in there and bend things. You just want to just work it. And that can go back in. I'll do the other pots. This wafer switch, it was saturated with that lithium grease, the white grease. I think it was lithium, I'm not sure. But I cleaned it all up, and I cleaned it up with the 401B. And this is actually, no, actually, you know what? I used Electrosolve on this, the zero residue, with a Q-tip. And I went through and cleaned up all the contacts and all the wafers. And now you just follow up with a tiny, tiny drop of red Deoxit just on the areas where this connects, the slides. Do both sides of the wafer. And there's 4 wafers you gotta do because both switches are double-sided. And that should be good for that. That's our speaker selector switch. Okay. Everything's done with switches and pots. Now, really nothing to do on this board. Nothing here. Just some tone control shenanigans. This is caps and resistors. Up here, all the caps have been changed. I removed two tantalum capacitors, replaced them with film. Now, there's a number of changes I made. These two caps here were 1 microfarad electrolytics, and I replaced them with 2.2 microfarad film caps. Reason being is, if you look at a schematic, it says 2.2 microfarad, not 1 microfarad. So in the production change, they decided to put 1 microfarads in. I don't think it's going to make a lot of difference to the sound. Usually when you go with a bigger capacitor like this in the signal path, you're going to end up with better bass response. That's the theory anyway. It doesn't happen like that all the time. It depends on a lot of things like the circuit impedance and frequencies and so on. But if you put in a larger cap, it usually helps with the low bottom end. So that's why I went with a bigger cap on these two positions. These 100 microfarad caps, these are power supply bypass, and I added a small MLCC chip capacitor that's 470 nanofarad, just to help bypass. Audio grade caps for these two. These are 3.3s. And if you go up and look here, this was another tantalum cap I replaced with a film. Replaced 4 transistors. These are now KSC 1845s. And everything's ready to go here. Just got to solder it all back together and clean the back of the board, and I'm done. Now I just got to move my attention to the phono stage. It's a very simple phono stage. It's got 2 tantalums I'm going to replace. These are 1.5 microfarad. I'm going to replace these with film. 2 100s, and this is a 0.47 in these two positions, so I'll leave those as 0.47, but they'll replace them with film. And then these 4 transistors will get replaced as well. So that will be the phono stage complete. When I remove this switch, you have to remove the nut on the phono jack too, headphone jack, and you pull it out as an assembly. This thing was impeding my progress, so I had to remove this screw from the tuner. And this is a ground, and this screw was loose. And you can see those 2 caps connect to the center terminal of this terminal strip. And this ground was completely loose. So this here is a resistor and a capacitor in series to ground. And this goes for, not exactly sure where this comes from. This comes from where the headphone connects. So I think they're trying to cut down on some high frequencies with the headphone jack. But the headphone jack is completely online. It doesn't matter which position you're in, the headphone jack should be completely online. So this might be the Zobel network for the amplifier. So that would be your high frequency path to ground for the amplifier. But when you put that in, make sure that screw is tight. Okay, onto the power board. Let's clean up this mess. So what we have here is well, maybe that's too much light. This transistor's flopping here. And there's a capacitor missing there, and a capacitor missing here. Somebody moved them to the back side of the board. Now, this transistor, all the pads are completely gone, and you might as well remove that because it's really not doing us any good right now. I think somebody tried repairing it and they just kind of crapped the bed and then just left their mess behind for somebody else to clean up. So let's pull this one out. This is a 2SD 2012. Now it's supposed to be a 2SD 330 general purpose power transistor. This is probably a good substitution. We can use this transistor if it works. I have to test it. But we have no pads. We have nothing to solder to. All the pads are missing. So what I propose to do is mount the transistor up on the steel here, drill a hole, mount the transistor, heat sink it onto the steel, run 3 wires down to the board, and that'll eliminate a lot of heat in this area too. This resistor here, I think it's supposed to be a 220 ohms. Somebody put in a 330. I don't know if that's correct. I'm gonna have to go through and check a lot of stuff here because things look really weird. They moved caps around and tried repairing it, but they didn't do a very good job. They didn't finish it. And this is all just charcoal here. Yeah, this is a mess. So let's fix this up. Yeah, like I said, I'm going to mount the transistor up high. It'll get a lot of heat away from this board. And these caps are probably all done. This one, I pulled it out and measured it. It is 1,000 at 50 volts, and this measures at about 750, so that one's garbage. Let's try this one. This one looks like a... Actually, first let's get rid of these wires. They're in the way. Okay, let's get rid of this one. Okay, I can get these out of the way now. All right. Actually, I'm curious what this is here. It doesn't look like it's been changed. That says 4,700 ohms. All right. Put that back. Yeah, I want to check this cap here. Let's pull this cap and check it. This is a 220 at 50 volts. It doesn't look... Huh. Well, let's see what it says. Yeah, it's bang on 234. It's got a ESR of 170 milliohms. It's not bad. This one next to it doesn't look good. So 470 at 50 volts. 51 microfarad, 101.3 ohms. Not great. Okay, I'm going to get this fixed up. Yeah, I changed my mind. Instead of putting the transistor up top, I decided I'll just drill a hole down here and place it under the chassis where it's not going to be so visible. This is going to be a good spot for it, I think. And then I can just connect the wires. Connect the wires up, and we're done. Okay, working on the power supply. So there's two regulators here, this one and this one. They both run off this this winding here, the rectified, and there's 1,000 microfarad 50 volt. This cap measured around 750 microfarad, so it's out, and I replaced it with a 2200 50 volt cap. Okay, so that's sorted. Now we had two regulators. This 2SC875 is looks like about a 33 volt regulator, and it feeds the phono stage, the 2 amps there, times 2. There's 2 amplifiers, and then there's a microphone, times 1. So there's 3 amplifier stages this feeds, low current amplifier stages. This one here, this regulator here, this is a 2SD330. That transistor was changed out to a 2SD2012, which is a good substitute, I guess. But this transistor was not even connected in circuit. It was completely removed from circuit, all 3 legs. And I found also this Zener diode was dead short. Okay. These caps were replaced. at some point by somebody, and they put used caps in, different voltages from what's here, but that doesn't matter. They were holding up. They were pretty weak, but all the caps got replaced. This 1.2K resistor is missing. Somebody took it out, and somebody replaced this 220 ohm resistor with a 330. What is it, 5 watt? No, 3 watt. 3 watt. Okay. So you guys, as you can see, somebody's been in here monkeying around. So let's see here. This regulator circuit was working, as far as I can tell. It got all new caps. Now the 2SC875 I have right here. I think I'm going to replace it. It tests absolutely fine, but you can see it's seen a lot of heat. It was wrapped up in this heat shrinking, and it's probably still fine, but I opted to replace it with a 2SC2383, and we'll leave it at that. Now this transistor here, the 2SD2012, I'm going to leave that in there, and I'm going to connect it back into the circuit. I got new caps, I got a new Zener diode. I replaced this Zener as well because this one was measuring about 35 volts, so I replaced this one as well. But this resistor here is missing. This is the biasing for this circuit here. Now what somebody did is they connected on this line, they connected a 4.7K straight from here to bias this. And I'm going to see how this works. I have a feeling I'm going to have to remove this and put this back. This is all up in the air because once I power it up, I'm going to see how the circuit performs. I'm going to see how this transistor performs in this circuit, and I'm going to see how this resistor performs in this circuit. If this doesn't work and this resistor doesn't work, I'm going to be changing values around. This is a more high current. This one supplies tuners. Alright, and both our tuners are dead right now, obviously because this transistor wasn't even in the circuit. So once I power this all up, we're going to evaluate voltage drops across this resistor, and I'm going to see how this is regulating and how this is regulating. I might make adjustments to these circuits. My main concern is heat dissipation. You can't get around heat dissipation because this is a fixed load, and this is a fixed load, and this is a fixed voltage. So you're going to have dissipation no matter what you do. Is it going to be with the transistor, or is it going to be with the resistor in front of it? You know what I mean? So once I get all this powered up, I'll evaluate, and then I might make some changes here. But as far as I can tell, everything's sorted and it's ready to go. Once I put this transistor back in. Look at the sneaky buggers at Sansui. So this is the main power fuse on the primary. It's a 5 amp. And look what they did. They put another one in series, another 5 amp fuse in series that's hidden. So don't oversize this fuse because it'll blow this fuse and then you'll be wondering why it's dead and it doesn't work. Sneaky buggers. So I'm going to replace this cap here. This needs to be an X-rated X safety cap. I'm going to replace this cap here. This is 0.0047 microfarad, 800 volts. This needs to be an X-rated safety cap. I'm going to remove that and replace that. And then I'm going to put a new power cord on. Power cord goes up to this socket. It's going to be tough to do. I might have to just loosen the back panel off and move everything out so I have room to work here, I think. Alright, so the main power filter caps, they're 50 volt, 400 or 4700 microfarad. They test out around 3900, 4000 microfarad. So I want to replace these. Now, I have a couple options. I could take a cap, this 35 millimeter diameter, and replace it with these. These are 8200 microfarad, 50 volt, 63 volt. Now I don't want to put little stubby caps in. What I'm going to do is I'm just going to leave these in place. And Sansui left us with another option. We have blanks here for 2 filter caps, and this is across the power rails. I could just disconnect these two and just install 2 caps here and be done with it. And that's what I'm going to do, I think. I think that's the... instead of making it look funny, I don't know, I don't like having short little caps in the place of the originals. It just doesn't look right to me. But some people are about looks, some aren't, some don't care, they just want it to perform. But this is where they're going to go, I think. I'm going to do that. And we'll get this thing up and running. We're just about done. The tuner is all recapped. The power board is done. You can see here I have the driver board. The driver board is finished and ready to go back in. I tested these semiconductors, they're all good. I treated these pots. They're working fine. I'm not going to get carried away with replacing everything in sight. Unless there's a problem during the test, I'm not going to be replacing parts. I tested all the components, tested the resistors, they're all within value, which is good. Yeah, so there's really no need to do much to this other than change caps. So we're going to put this all together pretty soon. We're going to power up. Okay, when I first tested this relay, it was testing in the hundreds of ohms relay contact resistance. Let's try it now. Once you work a relay a bit, it kind of cleans itself. It's kind of self-cleaning operation. As the contacts open and close, they microscopically they wipe against each other, and that's where you get the cleaning action. Let's try this again. So what are we at here? All right, I'll show you. So we're at 200 milliohms on that side, and it seems to be unstable. It's moving around. If I grab the relay, it moves. See how it's not stable? If I click the relay multiple times, it kind of gets better on its own. You can see, well, it's down to 100 now. Well, no, went back up to 150. And then, well, we're back to 300. So, yeah, it's got a mind of its own. Let's try the other side here. Let's see what this reads. And about the same. 200 milliohms, which is unacceptable. Should be around 10 milliohms. I keep clicking this side. This side's a little better, a little more stable, more consistent. But like I said, when I first tried it, it was in hundreds of ohms. And that's the reason why the channels cut in and out and they're distorted. Now this thing, it looks like somebody put, it's been diddled before. You can see the sides bulging and so they're not snapped in. This doesn't quite fit in that notch. I don't think this is the correct cover for this relay. I think somebody subbed in something else. Let's pull this out. Or is it glued? I think it's glued, to tell you the truth. It's not moving at all. I'm going to have to pry on it a bit. I just don't want to break anything. Yeah, I think it's been glued. Yes, it has been glued. Look at that. You know what? I'm going to see if I have a relay. Well, almost, not quite. See, I have relays, brand new ones, and they're 4-pole, not 2-pole, right? You could use these if you cut off all these pins in the middle and then just use the outside ones, but that's kind of wasteful. You're using a 4-pole relay for a 2-pole job. What I should really do is invest in getting some of these 2-pole ones, and then I can use them directly. Another problem is these are solder tabs and these are PCB pins, so they wouldn't fit the hole. I'd have to do something there, drill them out or something radical like that. But this is a modern equivalent of a relay. Quality's gone way up over the years. So, oh, it's even got a little LED. And how does this work? It's got a little diagram here on the back. I don't know if you can see this diagram. Bottom view, it's got 2 coils, it looks like, and the LEDs between. That's really weird. All right. Come on. This is really glued down. Let's see, this side is free. This side is free. And this side is free. It's just this one corner holding. Okay, let's see. Come on, baby. Wow, is that ever holding? You have to break this. There we go. All right. Yeah, there's quite a bit of tarnish on these. And you can see the tarnish on the contacts. And then there's tarnish on there. So we'll polish this up and then we'll get the milliohms back to normal. Even the tops. Okay, I gave them a polish. I know you can see the difference here. You can see how the gold really pops when you, the gold plating. And then here's the contacts. You see a little dot in the middle there on each one. That's, I don't know if you can buff that out. It's not really important either because when you reassemble it, the contacts won't exactly meet where they did before. It might be a little bit off, so you might have fresh surface. So what it is, I used, my go-to method is Silvo polish. And this time I tried a little different. You put a buffing wheel on my Dremel and these polished up really nice. Clean them right up. These ones you can't really get into because it just shreds the polish buffing wheel. But we'll put it back together. Put our spring back on. Where is our spring? Put this back together. Okay, you see we have a problem here. Why is this collapsed in? Alright, let's straighten this out. Now very carefully bend them open so you can get in to clean them, but then you have to bend them back. Alright. It's still not matching. I have to pull this out more. Right about there. Okay, let's check contact resistance. Alright, let's try this. Oh yeah, that's much better. Here, I'll show you. Okay, here's one side of the relay. 15 milliohms, pretty acceptable. I like to see it around 11 or 12, but 16 is okay. Let's try the other side. Okay, here we go. 14. little better. And you can see when you go click in and out, it always comes back to the same value. That's what you want. You don't want it changing values and doing weird stuff. So that's good relay. I'm going to put that back in. Alright, now we're on to lighting. The client supplied a kit, so we're going to try using that. Let's get rid of this. Alright. So, it uses the fuse style lamps. And it supplied me with 5 lamps. I don't know how many we need here, but there's one on the meter. Let's remove this little cover. And then we have full access to this first lamp. That's going to need a clean. Can't get my hand in here. Let's just pop it out. So, what it says is 7 volts, 300 milliamps. Okay, there's our original lamp. Stanley, 7 volts, 0.3 amps. And I don't know if you can see this. The meter's glued in pretty good. I'm not going to pull it apart. Everything looks okay. Problem with these incandescent lamps is that they bake the back side of the meters and your dial scale, and this plastic, instead of being white, it turns to a brown, dark brown. And then the lamp looks dim, even though it's a brand new lamp. It looks dim, and it's, let's see, these look like they have LEDs in them. 4 LEDs on that side and no LEDs on that side. So depending on how you point this, you could take a little pen, wherever you see the LEDs, you could mark on the, that's your front of your lamp, and then you can position the lamp any way you want depending on the brightness you want. You can have it shining down and just a little bit of residual light coming in, or you could put it directly on and have full brightness. Let's try it this way first with full brightness. Let's see if I get this orientated right. Okay, just snap it in place. There we go. And that one's in. I'll wash the cover and put that back. Now we have these. We have 2 screws here. Be very careful with all the plastics here because they're very brittle and dried out from the heat and aged. So I think this should come out now. And there we go. We got 4 lamps in here. 2 of them are working, I believe. We're going to get rid of all of these. Now if you want, you could take this, disconnect it from the wiring, and take this plastic and wash it out. You're not going to get it much cleaner than what it is, but there is some dust staining on here. Most of it is just aged plastic. One What you could do though is cover up all the contacts with some tape and just hit it with a spray paint, white spray paint, just to whiten it up again, and that will increase your light output considerably. You have a lamp here that looks like it's welded itself in place with some ancient electrical tape, and it's not pulling out. Somebody glued it. I think they did glue it. This is a stereo lamp, I believe. Yeah, it's a stereo lamp. And I don't know if it works or not yet. We don't know if it works. Maybe I'll leave that alone for now, and we'll try it and see how it goes. You can see this smoke staining on the top of the lamp housing, and on the bottom it's fairly clean. You could actually take this off and wash it. See, it's got a film of dust. I'm going to clean this up a bit. Okay, that cleaned up nicely actually. It came out a lot better than what I expected. It's got a film of kind of a brown gray film. So these are 8-volt lamps. Now you have a choice. You can have the lamp with the LEDs pointing straight up towards the dial face, backside of the dial face, or you can point it back or to the side and use the reflective light. I'm going to try the reflective light today. Let's put these in. You can see where the LEDs are just by looking through. These got cracks in them. Some manufacturing. Let's see here. Come on, what are you stuck under there for? Right. And last one. Okay. Put that back on. I need to power up for the first time and set up the amplifier, so we'll do that next. And then we'll see how the dial face looks. There's something worth noting here. You can remove the tuner assembly from this receiver. It comes out as a unit with the dial lamps, the tuning dial cord, and everything. It comes off as a unit if you just remove it. Actually, they have all the cables are held on with removable pins. You can actually pull the wires off. Make sure you take note of where they went. And see all here, these are all removable wires. They're not soldered. And you can actually remove this whole top assembly and take it out for servicing if you wanted, with the dial face, everything. And then that just leaves the bottom portion of the chassis with the tone amplifiers exposed from underneath, from above. And yeah, it makes servicing a lot easier. You just got to remove these wires, and might have to desolder one or two, but it does come out as a unit. It's kind of a nice design. I like that. And you don't have to worry about dial strings breaking or disconnecting dial strings and trying to figure out how to connect back up again. It's all like one assembly. Alright, I'm ready to do my first power up, and let's go through this and do our DC balance. So let's turn it on. Hopefully we get no smoke. Relay click right away. Settling around 12 watts, which is good. Alright, so we have our millivolts and millivolts. So let's set this up. Let's do the left channel first. That one's pretty good. This one here. Can you see that? No, my hand's in the way. Maybe that's better. No, it's not. Okay. Turn it right off. How about that? Then you can see. Okay, let's go this down to 0. I'm not a big fan of this meter, the way when it auto ranges, it jumps all over the place and gives you weird readings. See how it does that? I don't like that. Okay, let's keep going here. Millivolts. I'm down around 2 to 6. Yeah, it's pretty close. I'll leave it at that. That's millivolts. This is millivolts. I'm happy with that. And our dial face looks like it's lit up pretty nice. I have a interesting. First, let's do the bias adjustment, and then we'll try out the tuner. I'm interested in trying this tuner out and see how it sounds. Now, according to the service manual, these are your power fuses for the amplifier. What they want you to do is lift this fuse and this fuse for left and right channel. I don't know which is which, doesn't matter. You put an ammeter across the fuse, and then you measure 19 milliamps with, and you set it with the bias trim pots, this one and this one. Now, I got my ammeter set across, and it's set for milliamps, and it's across the meter, but the fuse is shorting my meter out right now. So all I gotta do is lift the fuse up, and we'll get our reading. It's powered on right now. So let me lift this fuse. Be careful not to short anything out here. Actually, I need something that's gonna, I'll try tweezers. Something I can lift up with. Let me try pulling this fuse here. Okay. And our current hasn't changed. That's surprising. So let's try tweaking the channel here. I think it's this one. Let's try this one. See if we get any adjustment. Okay. Wrong channel. We got to do this one. Getting no change on my watt meter. It's almost like we don't have a connection. I'm wondering if the fuse in my meter is gone. So let me pause here. I'll check my equipment. Okay, I had it plugged into the wrong port here. I was doing volts, ohms, and hertz capacitance, so I should be in this one for microamps and milliamps. Okay, so now we're set. So let me lift that fuse again. Lift the fuse. Okay. And we're at 12 milliamps, so let's adjust this. Going down, I have to go the other way. They want 19 milliamps. I don't think this is a very good way to do it, because when you remove the fuse, which is a very low ohms, it's like in the milliohms, and you put a meter, which probably has many ohms, I don't think we're getting accurate power through our meter. Let me see here. I'll get it at 18.4. That's good enough. Here's the wattage, 13.1. Okay, I'm going to put the fuse back in. Let's see if this jumps. It did a little bit. Okay, let's do the other channel. Alright, here we are. We're across the other fuse now. And all I have to do is lift it. You could tie a little piece of wire or a string around the fuse to help pull it. Oh, see, in my stupid clip let go. Let me see if I can reconnect this. Because I hate this method. It just, and then you risk shorting things out. Okay, so we're back on track. Now we got 12 milliamps, or 12, yeah, milliamps. Let's turn up. Which channel is it? This one? Yeah, it was. So I'm going up. Do the same, 18 and a half. Right there. Our total power consumption is now 13.5 watts at idle. Now, let's put that fuse back in. For those who want to do it the old way, I can take a measurement of across the emitter resistor. Let's measure volts, millivolts. Let's get this reset. Let me go across the resistor. We'll see what we got. Come on. You know, in there. Can't see anything, and then I'm in the... Okay. So we only got like... Whoa, what's happening here? Why is the reading jumping? You get a jumpy reading. Anyways, it's reading 1.7 millivolts. So that should be your bias, but you wouldn't want to set it on the resistor like that. It's a pretty low setting. Okay, enough of this. AM's working.
Words out. I don't know if CDC is going to put the axe on those. Jet following unexpected car troubles, home repairs, an illness, or a divorce.
AM's working good. Let's try FM. Yeah, I'm getting noise in stereo.
And back then, and I know. My man with a scrub book. Ces gens-là disent qu'ils veulent que c'est vraiment.
Everything.
It's working good. Just needed some power.
Mitsubishi inventory in Moscow.
Sounds really good. It's actually pulling in pretty good stations just with a chunk of wire for antenna.
Or that
So.
you hear music from Hosier. He just now.
Yeah, very good. Okay, let's wrap this up. I think what I'm going to do is go through and do a dial scale alignment. This one's really far out. I'm tuned to 102.9. The pointer should be over here, and it's like 1 centimeter to the left. It's way out in 101 land. So yeah, I'm going to do a dial scale alignment here and just get the accuracy back. I think the tuner's fine. I think it's picking up stations great. I don't think any alignment's going to fix anything there. It's already picking up good sensitivity, selectivity. I think we just need to fix the accuracy. So I'll do that off camera, and then we'll get on to some power tests. Okay, now I was checking power supplies here and I got a problem. This supply here is regulating to 12.5 volts, which is expected. That one goes to the tuners. That one's working fine. This regulator here is not regulating at all. It's putting out 44 volts, and it should be only 33. And I have a suspect that this diode I put in maybe is open. I don't see any. I tried measuring across it, and I see 40 some volts across this. 44 volts. So I have to investigate this regulator here and see why it's not working. This one seems to be okay with this 4.7K resistor in place and this 1.2K missing. So I'm going to leave that alone. And it also has a 330 ohm resistor here instead of a 220. It seems to be working fine. But I'm going to check this one. I'm going to check the voltage drop across this one. And we're going to check what's going on with this. Maybe my transistor is shorted or this diode is open. We'll have to see. Let me check. Okay, I'll show you some weirdness here. So this diode here, this Zener, that's ground potential, and then this is the other side, 13 volt Zener. Now the second Zener, which should be ground potential, measures 13. I don't know why these two are connected together like that. There's a trace underneath here that connects these two together. This should be a ground potential and this should be a ground potential. I don't know if there's a mistake in the printed circuit board. And then the other side I get my 44 volts, which is way too high. And if I look at the schematic, this diode here, this is the 13 volt diode and it's connected to ground potential. And here's the 33 volt diode connected to ground potential. But it's not. It's connected, this diode is connected to this diode through a trace on the board, which looks like a mistake. So I'm going to have to rewire this diode here, and then we'll get our supply back. So here's a look at the mod I made. I just moved the leg from this hole to this hole. And this is a ground trace here that's running along the outside. And it's going to solder those two together, and there's our grounds for both diodes. I don't know why this is like this. This is not legit. Maybe they had planned on different value diode on there to regulate one diode from the other. Doesn't make sense why they would do that, but anyways, it's changed. Okay, now I made the change. Our voltage has returned to normal. We got 30.8, 31 volts. It's pretty good. This is our supply for the phono stages, so I want to make sure that's right. So I went through and did alignment on the dial scale, and I also peaked up the RF for the low end, 88 megahertz, and the high end, 108 megahertz. The low end being these tuning coils, and the high end being these tuning capacitors. It made a huge difference. It just woke it right up. And see here, I'm tuned to 107.5, my tone. All the stations that are coming in now. Even this one here I wasn't picking it up before, but now it's 3 bars and it's in stereo. Yeah, it's got a really nice tuner and it's working good. Alright, we're wired in for a power test. Let's do this. 1000 hertz. No, I got a 440 hertz tone this time. So let's turn this on and see if we have our tone coming through. We need auxiliary. There it is. Left, right. Controls are clean. Muting. Okay, let's shut that off and put on our scope. Let's turn it up. There's clipping. Take it back down. I'm going to go with that right there. That is That's our limit, and we got 20.13 volts. No, actually 20.10 volts RMS. So let that cook for 10 minutes. Now, I didn't mention this in the video at all, but I did remove these 4 power devices. It's quasi-complementary, so they're all NPN. I removed all 4, cleaned the heat sinks thoroughly because they were all caked with dust on the outside here. And new heatsink compound, reused the mica washers, everything put back together. So yeah, we're looking pretty good here. So let's just go for 10 minutes and then we'll see how it looks. Okay, we're coming up to the 10-minute mark here, and everything's going according to plan. Nothing's really getting hot either. No, there's really no. Let's check it out. Okay, what do we got here? We have about 45. Oh, here we got 53. So that's our peak. 53 is our peak temperature on heatsink, which is doing pretty good. Can't measure my heatsink here because this is up in the 90s. Yeah, definitely. So I think it's pretty good. Let's go to some square waves. Let's reduce power. Turn these. Reduce power, and let's go and do some square waves. Now we still have that funny squiggle on the top trace. So obviously everything I've done to this made no difference on that. So we might have a bum part on the tone board. I'm guessing, let's see here, treble control. Okay, let's do some frequencies here. It's 440 hertz, let's go up. Okay, 1 kilohertz, 5 kilohertz, 5 kilohertz. Let's go up. 10 kilohertz. 15 kilohertz. Something's funky with that left channel. So, okay, well, let's end the test there. I'm going to do some investigating as to why that left channel is making that awful spike, and see if I can figure it out. I have a bad cap somewhere in the tone circuit, maybe. That's what I'm guessing. Let me try a few things. I'm going to try filters and controls and tone controls, and we'll see what we can make out of this. So I'll bring you back in when I know something. Okay, here's a look at the signal going into the power amplifier. I'm going to crank it up now. You're getting a lot of noise on this. You can see I got my channels backwards here. There are 8 channels on top, left channels on the bottom, and we're still getting that spike. So somewhere in the preamplifier we got a problem. Okay, I pretty much isolated it down to this circuit here. Between this point and this point, somewhere that noise is being generated. I have a feeling it's this cap here. This cap, this cap, this cap, this cap have all been replaced. And these are the tone caps. I checked a bunch of these already and they're good. Or no, I haven't yet. Sorry, I haven't. There is a styrene cap in here. Maybe that's the problem. The styrene caps can go bad. Let me check. I have to pull this board out and check all these components. It might even be a FET. I kind of, I don't know. I kind of highly doubt that though. it looks like a capacitor problem. We're not having the proper yeah, so let me percolate on this for a while. Okay, we've got a clean square wave now, and it's both channels, and it's looking good. So what I did basically is just chase my tail on this preamp circuit. Pretty much actually pulled a lot of, well, I didn't pull a lot of resistors. I pulled a lot of all the caps out and tested them. They were all fine. I actually swapped FETs from one channel to the other. That didn't make any difference. But this 100K resistor here on the tail end of the circuit is kind of like a impedance shunt. And I pulled those out and put those back in a few times. Couldn't find the problem. I did replace these 820K resistors right here, these biasing resistors. They were out of tolerance. On one channel was 835 and the other one was 815 or something, so there's an imbalance there. I replaced both of those, and pretty much it. I was really at a loss at what was causing it, because I don't think I found the solution. I replaced both these 220 nanofarad caps with new ones, but they also tested fine on the way out, so I don't know what I did, but it's working now. That's all I care about. So we're going to put this back together and wrap it up. Okay, so this is Future Trevor. I've had this on the bench, listening bench, for about 2 weeks now, listening to it, and I gotta say it sounds great. It sounds fantastic. It's got a really nice balanced sound to it, with regards to both channels working the same, doing the same work, and they're in unison. But we developed a little problem here. I don't know if you can see what it is, but I'll point it out to you here. See? We got a bum LED in our LED retrofit kit. This didn't appear until about 2 hours after I was doing the listening tests. And if you play it right, see, there's kind of fading out. And it's not working as it should. So obviously I can't return this to the customer and have it, work, because that's unsatisfactory. So I got to go back in, figure out something to replace that bum LED with, and then we can set this back to the customer. But this is disappointing. Okay, so it's typical. Trevor puts his foot in his mouth again. So this is what happens when you run your mouth off and you don't know the facts of what's going on. I assumed it was the bad LED, but I have a close look at this, and it looks like we have a broken connection. And it's right on the lamp holder. Let me see if I can zoom in. See if I can zoom in and you can see this. You're looking right here. There's the tip of the lamp holder coming out, and then there's a solder around it. And watch when I move this board. You see the movement between the two? So that's a broken connection there. And that is not a bad LED, so I'll resolder this right now. And that should be the end of our lighting problem. It's funny that you had a cracked solder there. Yeah, wires are going to want to come off now. Okay. Let me get this back on. All right. I think we're good now. It doesn't look great, but it is not. It's not a very good joint here. Let me fix this up. There, that's better. Okay. Okay. We're back together. And it seems like everything is honky-dory. I'm just more concerned about the bottom connection. top one's secure. The bottom one, maybe I should resolder as well. I don't see anything going on here now. Looks good. Alright, looks like it's fixed. Alright, that's it for this one. It's back together and it's ready to move over to the listening bench. So it's a nice little receiver. This little girl does pretty good. I'm going to enjoy listening to this one. So, take care. I have another Sansui coming up. It's a 9090, so stay tuned for that. Probably by the time you see this one, I've already started on the other one. Since it's about 4 weeks for me to get the video out. But anyways, take care, and we'll see you on the next one. Thanks for watching.